Welcome to Math in Bytes. Here we break down problems by focusing not just on the ideas, but how they actually work. So let's get started. Today we begin with this problem. How many three-digit numbers have at least one repeating digit? So, how do we solve this? Let's begin with the most obvious method, brute forcing. Let's write every combination down: 100, 101, 110, 111, 112, 113, 114, 115, and so on. So yeah, this is clearly taking way too long. So at this rate, the competition would be over before we even finish half this problem. Let's try another approach. Another idea would be to try and look at every possibility of numbers appearing more than once. So let's try this out. So we can imagine that these two would be the same, these two would be the same, or these two would be the same, or all three of them would be the same. And we can figure out each of those cases. But that also takes way too long. This would take a decent bit of time, and time is atom precious in any math competition. So you could try using more advanced techniques here, but there's actually a much simpler method which takes much less time, and that concept is complementary counting. This is a topic which is actually quite simple to understand, but can actually save you a huge amount of time when doing counting problems. The concept is actually quite simple. So essentially, if you have the total, you can take the unwanted amount from that total to get the amount that you do want, or the answer, which sounds extremely obvious and childish, but is actually a foundational concept. So why should we care? Why should we do this? There are actually several reasons that we should care. So first of all, it saves time. When you're in a math competition, you have very little time and can't afford to spend it on problems like this. This method will give that time to the more difficult problems later. It also saves you mental energy. Similar to before, you can't afford to spend your mental energy on these sorts of problems, and you need to save that energy for the more difficult problems. If you spend all your energy on brute forcing the easy problems, you will be very mentally exhausted later in the competition. And number three, it's just a good habit to get into. This skill is necessary to get into the habit of using, as it will be essential even later on. If you practice using it now, your future self will thank you. Right, let's put this into practice. To begin, we find the total amount of three-digit numbers. So for this, we see that the hundredths digit can be any number from 1 through 9, since if it were 0, then it would be a two-digit number. So now, the tens digit can be from 0 through 9, since the previous rule doesn't apply here, since even if this was 0, it would still be a three-digit number. And same for the ones digit. So that would mean 9 possibilities for the hundreds, 10 possibilities for the tens, and 10 possibilities for the ones. So we multiply all these together to get 900. The next step would be to find everything that we don't want, which in this case is all of the three-digit numbers that don't have repeating digits. So for this, we know that the hundredths digit can be anything, except for 0 again, because that would be a two-digit number. So in this case, it would be 1 to 9. The tenth digit, on the other hand, it can be 0 through 9, except we gotta be careful here, because the tenth digit can't repeat the hundredths digit. So in this case, we subtract 1 from the total, because it can't be this. Now the ones digit, on the other hand, it's also 0 through 9, except here, it can't be the tenth digit or the hundredths digit. So that way we would subtract 2. So we have 9 possibilities for this, 9 possibilities for the tens digit, and 9 possibilities for the ones digit. We multiply all of those together to get 648 as an unwanted amount. So now, we go back to the original question. So now, in this case, let's put complementary counting into practice. So the total minus the unwanted amount is our wanted amount. So we take the total minus the unwanted amount, which we got before, and if we subtract them, we get 252, which is our answer. This is much simpler than the brute forcing method before, and is a great method overall for any counting problem, where directly finding the answer is time-consuming. So now, I have one extra question for you, and this time, instead of 3 digits, the question is about 4-digit numbers. This is more or less the same, and you can apply the concepts learned in the video to this, and this will be a piece of cake. Now, if you've solved it, or if you have any questions, feel free to leave a comment. I'll go over the solution at the start of the next video. Thank you for watching.